This is Unit 7, video number 2, molarity. Molarity is the way we represent solutions in biology and chemistry, so we need to be aware of that's the method that's going to be used in the laboratory. Nice thing about molarity is it tells us how many moles are dissolved relative to the liters of solution. So with molarity, we immediately have a particle association rather than a mass association. That's something like density would give us. So with this, molarity is going to be equal to the moles of the solute, what's actually dissolved, divided by the liters of solution, the total volume of the solution. We don't care about how much solvent actually went in. We just want to know when it's all done, what's the volume present, okay? So moles divided by liters of solution. So let's do a calculation here. We want to know the molarity if 2.12 grams of magnesium fluoride is dissolved to make a 25 milliliter solution. So we're going to make a 25 milliliter solution. You know what's going to happen here. We're going to take, we've got a beaker, and we put in 2.12 grams. Then we're going to bring it to 25 milliliters. But we want to represent this not as a mass relationship, but as a mole relationship. So first thing we're going to do is convert 2.12 grams into moles. Every mole of magnesium fluoride will weigh 62.30 grams. Calculate that, and we've got 0.0340 moles of magnesium fluoride. So that's our moles of magnesium fluoride. Now, we know molarity is moles per liter of solution. We need liters. Most, or a lot of times, I wouldn't say most times, but definitely a lot of times, your solution's going to be given in milliliters, especially if it's small. So here we've got 25 milliliters. That's going to be 0.025 liters. So I've got my moles. I'm going to divide by 0.0250 liters. Liters of solution. When I do that, pop it into the calculator, we're going to get 1.36 molar. And we would usually identify the dissolved substance, the solute. So we'd say it's a 1.36 molar magnesium fluoride solution. Now I want to take molarity and determine the mass I would have to use to make the solution. This is very common in the lab, especially when you're preparing solutions. We say, okay, we want to know the mass of sodium phosphate that's necessary to make 250 milliliters of a 1.25 molar solution. So we know we need 1.25 molar, and we know we need 250 milliliters of it. So we want to know how much we need to weigh out. We'll weigh that out, put it in, and bring it to 250 milliliters. Okay? Well, let's figure it out. Molarity equals moles divided by liters. So we can bring this over, and molarity times volume equals moles. That's a good way to remember it because a lot of times we're extracting the moles from the molarity volume combination. So molarity times volume, if the volume is in liters, equals moles. Okay, so let's take our numbers here. We've got 250 milliliters, 1.25 molar. So 1.25 molar times, and I need to take the 250 milliliters and convert it into liters. So that's going to be 0.250 liters. Multiply those two together, and I get 0.333, oops, 313 moles of sodium phosphate. So if I have a 250 milliliters of a 1.25 molar solution, it will contain 0.313 moles of sodium phosphate. The rest of it's water. So we know that. We would know the mass. That's what we were trying to find. We have the moles. Grams on top, moles on the bottom. 1, go to the periodic table, 3 sodiums, a phosphorus, and 4 oxygens. And we're going to get 163.94. Plug that into the calculator, and our answer is 51.3 grams. So to make this solution, I need to first weigh out 51.3 grams of sodium phosphate, put it into my container, and add water until it reaches 250 milliliters.